All right, so just going to look at some Year 9 linear relations, but looking at it as pattern recognition rather than algebraically to begin with. You'll see what I mean. So let's jump into it. So complete the pattern below. Um, you can see we've got 2 squares, then we've got 5 squares, then we've got 8 squares, then we've got 11 squares. We've got to draw the next one. So if my pen would work. So the next one's going to look like this, isn't it? We're sort of adding 3 underneath each time. So my 2 squares will be up there. And then it needs to go down. And there was 3 here, so it could be 4 in the next one. And it's going to go like that, and then like that. So that's the next pattern in the sequence. All right, so the number of squares for figure number 1, so we're just going to skip 0 for now. Figure number 1 has 2 squares. Figure number 2 has 5 squares. One sec. Yeah, so this is 1, you've got a 2, and then you've got a 5. It's just playing up a little bit. And then you've got an 8. And then for 4, you're going to have 11. And this one here, you've probably recognized the pattern. This one's going to have 14. Okay, and I've put 0 here because this is actually important. If we think about how the pattern goes up each time, it goes up by 3 each time. So if we did have a figure 0, then that would have -1 would be the number of squares in there. Now, obviously, that pattern doesn't continue. We can't draw a -1 square, but that's how the pattern would continue. Okay, so if we answer some of these questions, by how much does the pattern increase each time? Well, hopefully you realize it increases by 3 each time. Create a rule that relates the number of squares to the figure number. Okay, so the number of squares, hopefully you can see, and this is part of setting up our linear relation, is equal to this number 3, so 3 multiplied by the figure number. Okay, then we need to find out how many squares there were for figure number 0, because we either get a head start or we sort of don't have a head start. We're behind the game to begin with. In this case, we have to subtract 1. Okay, so how many figures would be how many squares would be in figure 97? Well, we can use this rule. So we know that the number of squares is given by this rule, right? Equals 3 multiplied by the figure number, which is 97, minus 1. So 3 times 97 is a bit tricky, but 3 times 100 is 300, minus 3 groups of 3. So that's 9. So 300 minus 9 is 291. Minus 1 is 290. So if we did continue our table all the way up to figure 97, there would be 290 squares. Use the table of values to plot a graph below. Use a ruler, draw an appropriate line. So what we're going to do is we're going to look at figure number 1 has 2 squares. And figure number 2 has 5 squares. Okay, and it's a bit tricky for me to use a ruler on the computer, but hopefully you've got a ruler. And what you're going to do is you're going to connect them, and I'm going to struggle to do it, but I'll do my best. Hopefully you use a ruler. It's going to bug me, so I'm going to do it properly. So that looks not too bad. Now it doesn't have to go through 0, 0. In fact, when the figure number is 0, we know that it was actually down here at -1 from our table of values. So it does not need to go through the origin. So as long as you have 2 points accurately drawn, you can draw your line, not a line segment. This line needs to show that it keeps going in both directions. Okay, so let y represent the number of squares and x represent the figure number. Write the rule that relates x and y. Well, we're just going to take our rule from before. Number of squares equals 3 times the figure number minus 1. But we're just shortening it. So we're saying y equals 3 times x, or 3x minus 1. Okay, and then what is the gradient of this line? Well, let's think. The gradient is given by rise over run. So pick any 2 points on the line. and calculate the rise and the run. So we can see if we make a little triangle here between these 2 points, we've got a run of 1 and a rise of, well, we go from 2 up to 5, so that's a rise of 3. So our gradient is 3 rise over 1. 3 divided by 1 is just 3. So we have a gradient of 3. Now that's no coincidence with this number here. The amount we go up each time is 3, and that is our gradient for this linear relation. Okay, what is the y-intercept? Now that we're talking about things in terms of x and y, we know that the y-intercept is where it intersects down here, because now this is our y-axis and this is our x-axis. So where does it hit down here? Well, we know that that coordinate, we know when the figure number or the x value is 0, the y value is -1. So if we look up here, that's this position here, isn't it? So that would be our y-intercept. Our y-intercept would be -1. Okay, bonus question. If there was 101 squares, what would the figure number be? Okay, well, let's use our rule here. We know that the number of squares is sort of our y value. We just sort of use shorthand. So 101 equals 3 times x minus 1. Okay, so some number multiplied by 3 minus 1 equals 101. Well, let's work this out. What we can do is we can sort of just think in reverse. We took some number multiplied by 3 and subtracted 1 to get 101. So if we add that 1 back to 101, we're going to get 102 equals 3 times x. And then we're going to do, all right, 3 times something equals 102. So x equals 102 divided by 3, which I can tell you is 34. Okay, but you're welcome to work that out using division or if you calculator if you must. So yeah, when there are 101 squares, we must be at figure number 34. So we can actually use a little bit of algebra to work backwards to find out what the figure number would have to be. All right, so that's how we set up sort of our first linear relation. Hopefully that made a bit of sense.